We propose SmokeSVD, a framework to progressively generate and reconstruct dynamic smoke from a single video by integrating both diffusion models and physically guided consistency optimization towards realistic appearance and dynamic evolution. We propose a novel and efficient smoke reconstruction framework from a single view by incorporating multistage, 2D novel view synthesis, and 3D reconstruction. We propose a method to synthesize a visually plausible side view image sequences using the physically aware diffusion model. We present a novel view refinement approach to progressively produce consistent multi-view image sequences by injecting view information and coarse 3D density field. Beginning with a front view input, we first synthesize a side view image sequence to serve as references. Our diffusion synthesizer is guided by spatial, visual, and velocity constraints through reconstruction of density and velocity fields across consecutive frames. We then iteratively estimate a coarse-grained density field and refine the novel view images, progressively introducing additional novel views from near to far. Ultimately, our pipeline outputs the 3D density and velocity fields, along with the dynamic inflow over time. First, we use side view synthesis to predict side view images based on the input and previously generated images. Next, we reconstruct coarse density fields using the input front view and side view images, and render images for nearby novel views. Then, we iteratively refine the novel view images and reconstruct density fields. This process yields multiple high-quality views to support fine-grained reconstruction. To reduce accumulated error, we propose a multi-frame training scheme that enables side view synthesizer to learn features from historically generated images and rendered images of reconstructed density fields. In the forward diffusion, a clean image is estimated from the noisy image, and this estimated image serves as one of the conditional images for the next forward diffusion. We begin with clear views and incrementally rotates the camera to render and refine novel view images from near, mid, and far views. The left and right images show the results before and after progressive novel view refinement. Qualitative comparison based on different methods on the scalar flow dataset. Video-based qualitative comparison of different methods on the scalar flow dataset. Video-based qualitative comparison between hours and fluid nexus on the scalar flow dataset. Video-based qualitative comparison between hours and new smoke on the scalar flow dataset. The same scenario on novel view at 120th time step. The same scenario from novel views in the video. Results for another scenario in the scalar flow dataset, rendered using Mitsuba. Results for another scenario in scalar flow dataset. We also test 3D Gaussian splatting on synthesized novel view images. We visualize the reconstructed smoke at different time steps by rendering it from 360 degrees views. Qualitative comparison based on different methods on the synthetic dataset. The same scenario from novel views in the video. Reconstruction results for a bunny-shaped smoke scenario without inflow, shown from input and novel views. Reconstruction results for horizontally emitted smoke scenario, shown from input and novel views. Reconstruction results for a multiplume scenario, shown from input and novel views. Resimulation result with added fluid-solid coupling and external force field. Comparison of the maximum values, divergence and grad of reconstructed velocity fields by side view synthesizer, with different loss functions at various time steps. Qualitative results at the 80th time step from the ablation study on using rendered images of the reconstructed density field as input for the side view synthesizer. If side view synthesizer is not provided with these rendered images during training, it is unable to utilize such physical process information during inference. These images show the ablation on novel view refinement. The red boxes give the close-up views for corresponding regions. The refined results on more novel views. We combine the NGT method with our refinement model. The video shows the refinement results of our model. The video shows the reconstructed results of our model. Thank you for watching.